All right, y'all should see my screen.
Yep.
Cool. And we'll get things kind of organized and go from there. So as always, I've got the go to modules. I've got the, where are we? We're right here. Second video lecture right there set up, as far as kind of going over big picture how to design your program. Like we talked about last class, I uploaded both the complete Unity project and just the scripts for the MailMaker program that we've been looking at, just so you guys can get an idea of how everything's put together. We talked last time about the fact that you guys should be starting on your program. And so I think, well, I'll leave it up to you guys, because I want to make sure these classes are effective in terms of the content that we're covering. I don't want anything to be, well, I'd like everything to be as timely and orderly as possible in terms of giving you guys the right stuff at the right time. So let me ask this. We can do one of two things today. We can either continue to look at that MailMaker program and get a better idea of how it's set up, or if you guys feel like you are comfortable enough and know enough to get started with your project, we can jump into the SDLC. Before you answer, we are going back to the MailMaker program at some point. When we look at kind of the interaction between classes, when we look at input output and how to write to text files and read from text files and that sort of thing, we will go back to that. So it's not like we're leaving it forever. But the reason, like I've said before, the reason that we did it at the beginning is I wanted you guys to be able to see how you should start your programs, or at least one way to start your programs. So yes, Ethan, last class is recorded. It's right here. You can also, if you go to Zoom and then go to previous meetings, this ITCS 3112, this is it right here, the 17th, which is 2 days ago. Yeah, this was last class. So you can just click on this and, oh, no, just kidding. Previous, oh, maybe it's cloud recordings. You can pull it in here. It's one of the two. It's either previous recordings, previous meetings, or cloud recordings, one of the two. But I also put it here just for organizational reasons, so you can see where it fits and what we covered. All right, so yeah, so either the class is set to automatically record and automatically upload to the cloud, but I have to go in afterwards and manually publish it before it'll show up. So that's probably why you didn't see it last night. Okay. That's also why I put it under the module section, just so you guys can know exactly what it was. You don't have to go fishing. Okay, so with all that said, do you guys need another class period of going over big picture project program setup, or are you ready to jump into SDLC content? Put it in chat or say it out loud. Only one person cares.
So if we did MailMaker, would it just be like what we did last class, or would it be?
Pretty much, yeah. We'll go through how the program is set up, specifically how classes interact with each other, because I think that is probably where a lot of, I won't say confusion, but where there are a lot of questions around like how you guys should create larger projects. Okay, so it's got it. Pretty unanimous. that will stick with Meal Maker for one more class period. All right, so we'll do that here. We'll spend one more day. So I will add today's lecture 2 right here, so you'll see it show up here. And then next Tuesday, we'll get started with this, which should work well in terms of when I moved the due date, which is next Friday. So that should be fine. Sorry, Walter. Yeah, there you go. You got outvoted anyways, if that's what you wanted to do. Okay, so let's jump back into Meal Maker. So I have Unity open. I need to close out of this. And let's open Meal Maker. Anybody have big plans for the weekend?
Going to Virginia Tech for like a Space Force like training some conference. Pretty cool.
Nice. You said Virginia Tech. What's the topic?
Yeah, so Virginia Tech is hosting like the first like space training for ROTC cadets. So it's like for all Space Force interested cadets to kind of come together.
That's pretty cool.
Yeah.
Space Force? Is that like what is Space Force? Like Army in space?
Maybe eventually. But right now they're like responsible for like protecting satellites. I haven't actually seen the Netflix TV show, but yeah, it is a real thing.
Yeah, I can imagine that we're getting to that point. That's crazy. That's pretty cool too. Sorry, Jacob, I don't think going to Olive Garden quite competes with that, but I'm sure Walter's going to have to eat at some point this weekend. So
my birthday's coming up on the 24th, so I'm probably gonna go out with some friends.
happy birthday. Let me guess. You're turning 20.
22.
22. That's what I was going to say. Somebody made me say 20. Well, happy early birthday to you.
Thank you.
Anybody else? Yeah, Walter, they'll give you that dehydrated ice cream. Have y'all had that, the space ice cream?
Can't wait. The space sandwich, the ice cream sandwich.
Yes. That's gross.
Yeah, not a fan.
Gotcha. Watching The Last of Us. Isn't that a video game? I haven't played it. The only games I play are like Switch kind of games. Mario, Overcooked. That's what you have when you have little kids. That's all you play. Yeah, that's right. I heard that it had a show, but I couldn't do Animal Crossing. It was too cuddly. Yeah, we played it for a little bit because we like the idea of like 4-player, so each of our kids could do something, but the 4-player in that game we didn't love because it was like one person had to be the leader and then the other 3 had to basically do whatever the leader wanted to do, and so it was not ideal. It'd be better if everybody could kind of go off and do their own thing and then come together when they wanted to, but that was it. And the guys that would talk in the game were so obnoxious. It was just too much talking and dialogue for us, at least. So we got rid of that game. All right, so let's get started with Meal Maker now that we got it pulled up. All right, so when we left off last class, we had finished talking about singletons. Well, kind of finished talking about singletons. We had kind of come full circle. And we looked at specifically 2 scripts. We looked at the GUI manager and we looked at the main menu manager. And the GUI manager, as we looked, was set up as a singleton. This is review. And we looked at different ways to set up a singleton. This way is kind of more Unity specific, although it could be done by just having this be called from the main method. Another way to do it, as we looked, was to simply use a public static get instance method. where anytime public static GUI manager, anytime you wanted to use the singleton, you would do so by saying GUI manager dot get instance dot whatever you wanted to do, and set it up by saying if instance equals whatever that was, instance equals null, then you go ahead and create it. Otherwise, you return instance, just like this. Okay. Why doesn't it like this? I guess we have to do this. Is it like that? Okay, it likes that. So here is an alternate way to do the singleton. So if it does not exist, create a new one, and then return it. If it does exist, simply return it. So this is probably how I would suggest you guys doing it. And the reason I suggest this is because the concept works both in Java and C#. This doesn't rely on any language specific tools in order to get it functioning. Okay. And then, and so I'll just leave this for right now. The way it is used is, so this, now we're in main menu manager. And for example, right here. So again, the main menu is this thing right here. When the program is running and this is open, that is the main menu. And so when we click on open meal calendar, here we take use of the singleton. Okay. And if you're using the setup that we just talked about, we would say GUI manager dot get instance dot meal calendar dot show window. Okay. And what that would do is that let's kind of run through this code. GUI manager is the name of the class. Okay. And because singletons rely on the use of static, we're going to access that static instance through the class name. Okay, that's why we say GUI manager. Then we're calling the static method get instance. Again, we know it's static because we're calling that method using the class name, not an object. Okay, so we're saying GUI manager dot get instance. And every time we access that instance, we're going to use this get instance method, because what that does is it checks to see, does instance exist? Like, have we defined it yet? If we haven't defined it, then we're going to go ahead and create it. And then we simply return it. Okay, so this is a very simple way to do singletons. And then once we get access to the GUI manager instance, then we're going to access the meal calendar that GUI manager has access to. The meal calendar is a separate window. Where's our meal calendar? Here's our meal calendar. And so right now it's hidden. And then if I show it, and basically when I call show window, it turns it on. Okay. Notice meal calendar is its own script. And so we're calling show window there. So we hide the main menu. So when we call open meal calendar, we hide the main window, and then we show the meal calendar window. Pretty basic. Okay. But this shows us the flexibility that a singleton offers, because otherwise we would need a reference to either GUI manager or we would need a reference to the meal calendar. And like I talked about last class, when you've only got a couple of different classes, it's not a big deal. But when you're dealing with maybe 50 different windows or even a dozen different windows, having to keep a reference to each individual one from each individual one is a lot, and it's very cumbersome, and it's not an elegant solution. And this is, again, the benefit of a singleton. Because we know only one exists, we can rely on accessing that single one through a static reference without having to keep a bunch of encapsulated references in each of the separate objects. Okay, big picture wise, does this make sense? Are you asking why is this Stone, are you asking why this line of code exists, the one that's highlighted? I don't understand your question.
So basically, when you have measures such as like calls upon the instance, not so sure if I'm being clear here, because like you have like used instance before the meal calendar, so and I see that sort of constant everywhere.
This right here.
Yeah.
Yeah, so this is an alternate way to use it. All right, this is how it's set up in the program. And the only difference is that in this example, we're using a method to get access to the instance where the instance itself is actually private. In this situation, we're just using a public reference. And so we don't need a method to access it. I suggest you guys doing this one because the method that I used is more specific to Unity. Okay. And so I'm showing you just different versions of how to do it. All right. Remember, last class, we looked up some basic ways to create singletons. And we saw that there's kind of a variety of ways to actually achieve the forcing of a single instance to exist. This is one way, using a public static field. Another way is to create a private static field and set it up like this. Okay, either is fine. I just showed you both, and that's why I deleted it here because I didn't want it to be confusing. If that makes sense.
Okay, so basically the instance is essentially a public method, right?
That's correct. It's a
Okay.
public field instead of a method that you would use.
Okay.
All right, 2 questions from chat. Ethan asks, is it bad to use C# properties instead of a method? No, it's not a bad thing. In fact, I use C# properties in most of my coding. I didn't use it here just because I ended up making everything public because I knew the scope of this program was going to stay in a manageable place and I was creating it for myself and I broke a lot of rules that you shouldn't break. So let's talk briefly about properties. Properties is a special C# thing. Java, to my knowledge, does not have them. And essentially the way it works is it's you guys in your Java class, 12, 13 were taught about getters and setters, right? And how when you create class fields or class properties, they should be private. And the way that you interact with those fields should be through methods. So if you need to change the value, you call set whatever. And if you need to get the value, you call get whatever, rather than making it public and just accessing it like that. Okay, that's what you guys were taught. Yes. Okay. So the downside to that is if you've got a class that has like 50 fields in it, creating getters and setters for each of those 50 fields is cumbersome. It's kind of obnoxious. And that's why some IDEs in Java will automatically create the getters and setters for you. Okay. C# solved that problem, solved that extra step by creating properties. And properties are variables, but they have built-in methods to them. In fact, let me see if I can, let me think for a second, because I use them, I'm trying to think of a good example. All right, here's an example. So if you look at this, these are C# properties, okay? And a lot of times you'll see them like this. Okay. And this particular class for Access Football holds the league configuration for a franchise. And so this is the actual file that gets written to memory when you save your file. Okay. That's what SGD stands for, save game data. And so if we look at this, this actually uses inheritance. We talked before about the syntax in C# for inheritance. Well, this is what it looks like. Okay, so the name of this class is SGD franchise data, which stands for save game data franchise data. Okay, the colon indicates inheritance. And so if this class didn't inherit from anything, it would look like this. Okay, it does inherit, and it inherits from a saved game data class. And so if you think big picture wise, we have lots of different types of data that we are storing. Right? So you play a game and you need to write different things to memory. And so, for example, we write user created teams. So you can create your own teams in the game. Those get saved separate. We have up to 4 franchise slots that you can start. Those get saved separate. All of your achievement data gets saved separate, your game settings, uniforms, all that sort of thing. Each of those exists in a separate file. And so I used inheritance to represent that. And so if we look at the parent class, we see we have just some very basic information that every saved file uses, like a file name, a timestamp, game version, username, and whether or not it gets marked as deleted. Every save game file has that, but so we inherit from that, and then each individual subclass has their own information. This particular information keeps track of all of the franchise data. Okay. Questions so far? I'm trying to give you background information so you understand why properties are used. Now, let's take a look at this. Properties are always going to be public. Okay. And the way it works is this is essentially a variable. So the number of teams in a franchise, but notice the capital letter. Okay. In C#, methods, classes, and properties get capital letters. It's just a slight difference between Java, or Java only classes get capital letters, but properties get capital letters. And so this is a variable, but we can also, use it as a method. So here's how it works. Notice after I declare it, I put opening and closing braces. Inside of the opening and closing braces, I'm going to put 2 different pieces of information. The first is how we get the information, and the second is how we set the information. So if I just put get, this means public, okay? And you don't put public, but that's what it means. It means that we can access this field outside of the class. Private set means I cannot change its value outside of the class. Okay. And so if you look at how this is used, we have 90 some use. Let me pick a different one. All right. So let's look at, well, that's fine. We'll look at this one. So if you look at how this is used right here, we can simply access that value outside of the class. So here we're in a different class. This is in Draft Manager. And I'm accessing the number of teams in franchise simply by using, like you would in a normal public variable, franchise data dot number of teams in franchise. Okay. But because it's private set, I couldn't do something like this. If I try to say franchise data dot number of teams in franchise equals 20, it's not going to let me do this. And when I mouse over it, it says the property cannot be used in this context because the set accessor is inaccessible, which means we have specified that this is a private set only. So we can only set the value of this field, this property, inside of the class in which it's declared. Just like you're used to using normal private variables, that's what private set means. And so essentially what this does is it builds in a getter and a setter. Okay. There are other things that can be done with this. For example, if we go to the hold on. There's a games, there's here's another example. What this does, this is another example of a field. This happens to be a static field, but it doesn't really matter. You can see how we have get here. We could just leave get as is. Okay, we could just do get private set like we had before. There's nothing wrong with that. Okay, but you can also override the basic get and set. And so here's what's actually happening. When we have just get, and you could even do set just like that, which means you could, this is like a regular public variable. What happens is C# is going to create for you automatically a hidden private field related to this. You don't actually see it, but it creates for you under the hood. And that's the value that we use to get and set, okay? You can also override the get and the set by specifying complete methods like this. Okay, so what this does is anytime I call game dot offensive QB, this method gets called. And what it does is it checks to see is which player's on offense, and then we're going to return that player's fifth or sixth guy in the lineup, which is the quarterback. And so this allows us to have actual methods where we're using this. So for example, if we pull up a random this right here, okay? So when I say this forces the offensive quarterback to get the ball, but who the offensive quarterback is depends on the results of this method that gets called, okay? So, and all of this to say, let me close out of this, all of this to say, if you are interested in using properties, which I would suggest you using, just do a little bit of research on them. They save you a lot of effort. And this is if you're planning on doing C#. Questions for me?
Are they similar to properties in JavaScript?
I don't know. My experience with JavaScript is a long, long time ago. And I don't remember properties in JavaScript. Sorry. Somebody else might know. All right. There was another question. Thomas, you said, is GUI manager an object or a class? So it's not a silly question because there's a lot of overlap in this particular situation. When you use the singleton design pattern, it is effectively the same thing. So the idea with object-oriented programming is the distinction between a class and an object. A class, as you were all taught, is a blueprint, and the object is the manifestation of that blueprint. It's the actual example instance of that class, okay? Singletons essentially break that pattern, okay, where there's only going to be one object. And so for all intents and purposes, the object is the class, okay? Because, I mean, so you can think of it like that, but it's better to think of it still, the class is the blueprint, the instance is the object, because where a class just defines what the values are, the object gives value or gives values to those properties, I should say. And so think of it more like when you're using the singleton, you are creating an object of the class, but you're forcing only one object to exist. It further complicates it by the fact that we're using static. And so because we're using static, everything is essentially at the class level. And so that's why I said you can think of it as the same thing, but it it doesn't really matter. I understand your confusion. So what does the constructor do in this case? So in this case, we don't explicitly create a constructor. As you see, there's not one listed here. Like Java, if you don't create a default constructor, C# essentially creates one for you under the hood. And so what happens is we basically have public GUI manager like that. This is it. It's just an empty constructor. So when a constructor is run, all that happens is the object is created. And then what gets returned from the constructor is the memory location where the object is created. And so when we have this here, we call the constructor, which is this right here, which essentially nothing happens. We're not setting any values because this isn't really operating as needing to create values just the way that it works. And then the result of this, what constructors return, is the location in memory to where that object was created. And that's what we are assigning to the instance variable. All right, so if we use a singleton and that class is used as the object, are we still able to interact with the other objects that we create in other classes? Let me wrap my head around that. So yes, let me read the question again. If we use a singleton and that class is used as the object, so here essentially we have GUI manager is the class and we're using a singleton and the object of that class is instance, and we are forcing a single instance to exist. That's what we're calling the object of that class. We create it here. Are we still able to interact with the other objects that we create in the other classes? Yes. And in fact, that's the main purpose of creating a singleton. It makes it easier to interact with those objects because what we have here are references to those other classes. And so we use the object, the singleton object instance, to then get access to all of the other objects. These are not singletons. These are just regular objects, even though there only happens to be one of them. We still access these in other sections like we had here. So here we access the singleton object, and then we use that singleton object to get access to other objects that we created from those classes. And so meal calendar is the object that we created from the meal calendar manager class. Okay. Did that answer your question, Zach?
Yes, it did answer the question. Thanks for clearing that up.
Sure. All right, Ethan, what is the difference between using a singleton and just making all the methods and variables static and accessing everything from the class? Not a whole lot. But you're going to run into some probably unintended issues with static. And so the downside to that is, one, just by using static doesn't necessarily mean that it's going to force a single instance. And using the singleton design pattern helps prevent unintended accidents like that happening. Second, you're going to force everything to be public when you do it that way. And you can think of it as kind of like a knockoff version of the singleton. And doing everything public and static will essentially achieve the same thing, but it will also lend itself to creating a lot of problems down the line. But it's good that you're thinking like that, because it is essentially the same thing, but using a singleton allows you to keep a lot of things private and protected, which is a better way to go about doing it. Okay, but good question. Other questions on this? Okay, all right, let's talk about this briefly, because the way Unity does this is a little bit different from how you will do this, and I want to kind of equip you guys with what you'll need. Nowhere do we actually create these objects, okay? And this might be kind of the next point at which you guys might be a little confused. Okay, so where exactly are we creating these? Well, we aren't. And the reason we aren't creating them is because they exist here. Again, Unity does things a little bit differently. And so the way it works in Unity is I design the window and then I literally attach a script to the window. Okay, so we can see here on this main menu, I have attached to the main menu, the main menu manager script. It's hard to say. Okay, and so we have the same thing for the meal menu, or let's do the calendar. So for the calendar, you see I have the calendar manager script attached to this as well. And so this is why you don't see any objects actually created in code, because when we attach the script to it in Unity, that effectively creates it. So let me show you what you guys will need to do about creating the objects in your code. So essentially what you're going to have in your big manager script, you can call it GUI manager, you can call it whatever controller, it doesn't matter what you call it, but you're going to have some sort of function that gets called when the program starts. Okay, in Java, this is main. I don't know what it is in C#. I think is it main in C# too? I don't code in C# outside of Unity, so I'm not sure. Let's Google it. Does C# have a main method? Yes, the main method is the entry point of a C# application. So same thing. So what you will have is you'll have some sort of main method. Okay, and so this is the same thing as the main method. Okay. And so what you're going to do here, you can create your singles in here if you want, but this is where you will create your other window objects. Okay. And so what we have here is we have references to all of these other windows. Okay. And the way it works in C# is here's our GUI manager script. And the way we keep references to them is I simply drag and drop references. And so the meal menu, we got that reference by dragging and dropping this right here. That's essentially how you set them equal. Okay, again, I'm showing you this in Unity so that you understand the way why the code is the way it is. This is not a how-to on Unity. Whoops, wrong button. This is not a how-to on Unity, but I'm showing you how you would do it in either just native C# or Java, so you understand why this code looks a little bit differently than what yours is. There's no way to drag and drop references in C# or Java. We need to sign them in code. And so this is where you would do that. In your main method, you would actually create all of the different ones. Okay, so if we're doing meal calendar, we would do meal calendar equals new meal calendar manager, and then whatever properties we need to pass or arguments we need to pass. This is how we would do it. Okay, and this works well in C# too, or in Unity. This is where you would actually create the objects. Okay, and then probably inside of the constructor, you would say, okay, when we first create them, then we are going to hide the windows so that they don't show when we first run it, and like that. All right, Ethan has a question. Is it better to place your main method for your program into the GUI manager class, or to use a separate main class where you create the instance of GUI manager? Yes, so I would, and again, it depends on the scope of your program and what it's actually doing. If you have a good bit of stuff that is running in the background, as in like non-GUI scripts, then I would suggest having a single entry point as, let me draw an example. So I would have something like this. Okay, so we have this is going to be our entry point, and this, we'll call this the main, it's too confusing. Project manager. Okay, so this is where main would be. Okay, and then from here, this is responsible for doing two things. Here will be GUI manager, and this will be the, we'll call it back end manager. Okay. And then from here, GUI manager can kick off the individual menus, and then this can kick off other stuff. Okay. So these are our sub windows, like the calendar, the side items, etc. Okay. And this will be other backend stuff. Does that make sense? This is just one way to set it up. And Ethan, you're right. This is a good way to do it. You do want a single entry point, and you want kind of fork from there to set up your different stuff. I typically have a lot of initialization methods that I call. So for example, let me clear this drawing. If we go back to Access Football, I'll show you an actual example. Franchise. So in the franchise manager, there are a ton of different windows. You've got awards, schedules, records, stats, your depth chart, all kind of trade windows, draft, coaching staff, all kind of different stuff. And so what I do is when the main franchise window gets initialized, which is when the user selects to go into the franchise, I initialize all of these separate windows one after another. Okay, and I've got to separate. Some need to get initialized first, and then some needs to get initialized afterwards. But you can see exactly how it works. And this is what I meant before when I drew that graph just a second ago, where it forks out. You have a single entry point. And so for this example, when the program first starts, when the game first starts, we don't need every menu, every window in the game to initialize and run its startup data. That would be too much. And so what I have is I've got kind of like gates almost. And so we have the GUI manager. And in fact, the way this particular game is set up is very similar to, oh, we actually have the circle. This would be way better. Yay for drawing tools. The way this is set up is actually a little bit different. So in this particular setup, we have, it's called Title Screen Manager, which keeps track of this is the entry point for the entire title screen, which has everything outside of the actual gameplay. And then from title screen, we initialize our franchise. Okay, franchise manager. And then from here, there are a ton of sub windows, and that's what we see here. These are all of the sub windows that we have there. This essentially acts as a gate. Okay, so we don't allow code to get past this point until the user decides, hey, I want to go into my franchise. Okay, and the reason for this is we don't want all of this startup data to run until we actually need it. And so that's why it's better to set these gates or set a single entry point and then control the flow from there. Yeah, kind of like using a hierarchy. That's right. Okay, and this is non-franchise stuff that gets initialized here. Okay. Questions on this? So the main takeaway that I want you guys to have from this is how to bird's eye view set up your program. And from that, here's what you need. You need a single entry point. Okay. And this will be our single entry point class. You want to name this something that is generic enough. I suggest something along the lines of project manager or something like that. Okay. This is going to have a main method. That main method is where you are going to initialize everything. Okay. That is where you'll create any singletons that you have, anything like that. And then from there, so again, like if this were a main method, here we call all of these separate initializations. When I draw these arrows to other classes, that's what's happening there. That's where we actually create those. Okay. And so what I want you guys to take away from this is the first thing you guys should do is set up that single entry point class. Call it project manager, call it whatever you want. Okay. You need a main method in that class because that's the method that's going to get called when your program runs. And then in that main method class, if you want to use singletons, that's where you'll set it up there. If you've got a lot of sub windows or other windows that you'll go to from that one, that's where you'll create those. Okay. All right, Thomas says, so are each of the windows their own classes in their own files, and do you just reference them in your own main manager by creating a new object of them? Yes, that's exactly how it works. Okay. So your project manager can be a singleton. That's totally fine. Like if you're looking at your program and you have a general idea of how many classes you need, if you've got like 5 classes total, just make your project manager a singleton and have a reference to all of those inside of project manager. So it would effectively be just like the GUI manager we talked about. If you have, a half dozen or more different menus or windows that you're going to be using, in addition to other classes that you need that aren't actually visible, like backend stuff, that's when I suggest separating. You could still make project manager a singleton, but I would further separate it and have a single GUI manager class that's also a singleton that manages all of the GUI specific windows. And then you have another singleton that manages backend or unseen stuff. Okay. And again, like we've discussed, like you guys have said, it's simply like setting up a hierarchy. The more stuff you have, the more it makes sense to create more layers of the hierarchy. Other questions on this? Good. Okay. All right, so in this case, if project manager was a singleton, you would initialize it in main before everything else. Correct. Correct. Again, my main purpose with taking these 2 or 3 classes to go over this information and show you actual examples is I want you to know structurally how to set up your project. Okay, that's the idea here. This is what I want you to understand, like how to do this specifically for your example. All right. All right, that's about it. Obviously, there's more that we could get into, but I don't want to overwhelm you with a bunch of information and kind of crowd out this knowledge and information. Because I think this is a good stopping point in terms of giving you the right amount of information so that you can get started with your projects. Okay. So let's stop here for today. I'm going to clear this. We don't need this. Don't need this. Okay. And I'm going to undo all of this. Okay. Take it back the way it was. All right. Questions for me?
I'm just kind of curious, but how do you exactly approach code and like make working methods if you don't exactly know the full logic of it? If that makes sense.
Yeah. So the best thing to do, and this is the way I kind of approach it, is you're going to do two things. The first is I find it helpful to create containers first. And so, for example, you know you're going to need this sort of project manager class. You may need a GUI manager class, like we've talked about. Go ahead and create those. And then once you have that space, that container, essentially, you can go in later and fill in the logic that you need. That's the best way to approach it. As far as actually looking at the process for creating that logic and how you go through it, do it one step at a time. And do it in the order that is like the very first thing that you would do in the program. Okay, and so start with, if you know you're going to need buttons, for example. So if we're looking at, where's the, create this first. Okay, and so what we have here is we essentially have 1, 2, 3, 4 different options that we can go from the main menu. Because you look at your program and you figure out what you need, start with that. And then start with what, or once you have this, the next thing you should do is, okay, let's get these windows to pop up. Okay, don't worry about the logic for what the windows need to actually do. Let's just get them showing up. So can I have this window show? Can I have that window hide? Can I go back to the main menu? And so you want to approach it logically one step at a time, but not let the actual implementation of what those windows needs to do get in the way. So create the container, create the structure first, and then you can go in later and fill in the stuff. That makes it much easier.
Okay, so it's like a prototype, right?
Yeah, you can think of it like that.
Okay, thanks.
Yep. All right, what other questions you guys have for me? Okay, well, if there are no questions, we will stop there for today. Let's take a quick look at Canvas. So I will upload the third video, which is this video right here. So you guys can go back and look at those to get a good idea of how to set up your project, the organization of the project. On Tuesday, we will start with this. Okay, it'll probably take us 2 classes to get through this. This will go over the software design life cycle, give us an idea documentation wise of how software is created, some different approaches, whether we're going to use a kind of a linear approach or an iterative approach to creating software. We'll start that next week. So that'll probably take Tuesday, Thursday. You do have a quiz. This is your very first quiz due next Friday. So a week from today, you have a quiz. It's like 5 questions, comes directly from this, should be super simple as long as you are paying attention. Your first milestone is also due next Friday. Again, we'll talk about this next week, but this is just your proposal. It's should be super basic. And we can go ahead and take a look at this, because what I'd like for you guys to do is over the weekend, get started on your project. Even if you're just creating those classes and creating the basic structure, get started. It'll make getting into it a lot easier if you've got something started. Okay, and so your first milestone, what you're turning into, simply the proposal. Okay, less than 1 page description of what it is that you're going to be doing. Here's a very simple, clear rubric for how it's rated. So do you have a description of the project and an overview of the functions? Function is what it's doing. That's it. Okay, so basic description, and then what it does, like how you can interact with it. Okay, and that's it. Again, we'll cover this more in depth to make sure there are no questions, but this and your quiz are due next Friday. Again, just follow the due date on them, and we'll chat about them more next Tuesday and Thursday. Okay. Any questions for me before we close out? Is what how you interact with the GUI? The functions? Essentially, yeah, it's how you interact with the program. Because remember, it doesn't have to use GUI, but if we were looking at the meal maker and I was explaining what the functions are, first I would give a description of what you can do. So the purpose of it is to better organize your meals for the month. It'll take out all of the tedious work of planning out meals and what you need, and it'll also help randomize so you're not having the same thing. Okay, so the whole idea is it helps facilitate meal planning. Okay, that would be the description. As far as the functions, you would explain what you can do in the program. So you can create meals, you can create side items. You can also specify the frequency that you want the meal to be, how many side items, you go into all of that. And then there's also a meal calendar that lets you, it will automatically randomize meals. It will randomize meals with side items that go with that meal. It will also give the user the functionality of swapping out either entire meals or side items for the meal. And that's what I mean by functionality. It's how you interact with the program. Cool. Other questions? Cool. All right. Y'all have a wonderful weekend. I will see you on Tuesday.
All right, thank you.
You're very welcome.
Also,
Have a good day.
One more question. Could we, did you say we could email you our project proposals before to see if they're cool, or?
Yeah, that's fine. If you just want to give me a quick 1-line, 2-line description, and that's only necessary if you're a little bit concerned that your project is either too big or too small in terms of scope.
Okay.
I'm happy to do that. Just shoot me an email.
All right. Awesome. Thank you.
You're welcome. All right, I'll see you guys.